Here's a great story about a gold crown and a dishonest goldsmith. The story also features density and the legendary ancient Greek scientist Archimedes. Our story takes place in ancient Greece a little more than 2,000 years ago. King Hero II of Syracuse decided one day that he wanted a new crown. I don't know why he wanted it. Maybe his old crown had gone out of style or something. It wasn't in with the kids anymore. So he takes some pure gold that he owns, and he takes the gold pieces down to the goldsmith, and he says, "Make me a new crown." The goldsmith takes the gold, and a couple days later delivers a beautiful new crown. King Hero loves it. He puts it on. He's like, "I look baller in this thing." But for one reason or another, the king gets suspicious. Maybe he just got some bad vibes from the goldsmith. And is like, you know what? I think that goldsmith might have swindled me. I think he might have cheated me. And here is what the king thinks the goldsmith might have done. The king is worried that the goldsmith took some of the gold for himself and he kept it. And then he replaced the gold with a cheaper metal, say like silver. And then took the gold and silver and melted it down, stirred it together, and used that to make the crown. So in that case, the crown would kind of look gold, but it wouldn't be made of pure gold because it would have this cheaper metal, the silver or something else, mixed in with it. So the king is getting increasingly suspicious, and he needs to know whether the crown is made of pure gold or if there is some cheaper metal mixed in. So he calls on Archimedes, who is an incredibly well-known scientist, inventor, and mathematician in ancient Greece, a great solver of problems. So Archimedes is summoned to the royal court, and the king says to him, "I have this crown. I'm not sure if it's made of pure gold. The goldsmith might have cheated me. How can we determine whether this is pure gold?" So Archimedes, who is a very sharp guy, thinks about this for a while. And he comes up with the idea of density. He's like, we will figure out whether this is pure gold by using density. So density asks us, how much does it weigh when a material fills a certain amount of space? Okay? So for example, styrofoam has a very low density. I have a bowl here of styrofoam balls. They're filling a certain amount of space, this bowl. And it doesn't weigh much at all because styrofoam has a very low density. On the other hand, if I fill the same amount of space with metal, I've got this big bowl of coins here. This is really heavy because metal has a high density. So we have the same amount of space that's filled with both. This is light because it's got a low density. This is heavy because metal has a high density. So it turns out that most materials have distinctive densities. So you can use densities to tell the difference between different materials. Now, even within metal, different metals have different densities. So for example, here is a list of metals from low density to high. Aluminum has a relatively low density. So a handful of aluminum, it's not that heavy. But on the other hand, the same handful of gold or platinum is super heavy because gold and platinum are really dense. Now, density is actually something that we can measure. There's a number associated with it. So Archimedes realizes that he can measure the density of the metal that makes up the crown, and then he can figure out what the number is and see if it matches up. If it's 19.32, okay, then it's probably gold. But if the number is lower, chances are another cheaper metal has been mixed in. So, in order to come up with this number for density, Archimedes has to measure the mass, how much the crown weighs, and the volume of the crown, how much space it takes up. Then he can divide the mass by the volume, get the density, and check to see if it's actually gold. Now the mass is easy. That's how much the crown weighs. So all he's got to do is put the crown on a scale. The volume though is harder. The volume, the amount of space the crown the amount of space that the crown takes up, that's hard to calculate, right? What Archimedes would really love to do is he'd love to be able to take the crown and melt it down. And then he could take the melted metal and make it into a nice block like this that has this very regular structure. And then he could just measure the length and the width and the height, multiply them all together, and figure out the volume is. But the crown, it has a shape that you can't easily just do math to figure out what the volume is. And he can't melt it down because then that would destroy the crown. So he keeps thinking and thinking and thinking, how can I get the volume for the crown when I can't reshape it into an easy shape where I can just do math to figure out the volume? He thinks and thinks and thinks, and he's just about to give up. He decides to take a quick break from his work and take a bath. And this is what he does. He draws a bath water, and the bathtub looks like this, and then he gets into the bath. He steps into the bath and he notices that the level of the water rises up as he gets into the bathtub. And he makes a tremendous discovery. He realizes that as he gets into the bathtub, his body is pushing the water away. And he realizes that the space that his body takes up pushes the water up in the bathtub. And so he realizes that to figure out the amount of space his body takes up, or the volume of his body, all he has to do is look at how much the water rose, because they're the same amount. And he realizes that is how I can measure volume. This is something that we do all the time in the lab. Let's say that we want to measure the volume of this weird-looking curlicue thing. We can't just use a simple math equation to calculate the volume of it, but what we can do is we can put it in water. And so we can measure that, say, the level of water in a graduated cylinder is 200 milliliters before we add this thing in, and then we drop it in the water, and the water goes up, and now it's at 300 milliliters. And that tells us that the volume of this squiggly thing is 100 milliliters, because it's now taking up space, so the water has to rise because it's been pushed away. So Archimedes realizes that he's made this amazing discovery, and he jumps out of the bath. He doesn't even have time to put clothes on, he's so excited, and he runs through the streets of Syracuse shouting, "Eureka!" which is a Greek word that means I found it, I figured it out. Now people use eureka all the time to say just that. I figured it out. It makes sense now. So Archimedes finally figures out how to measure the volume of the crown. He goes back to the king. They weigh the crown, they determine its volume, and they find that the density isn't right. The density is too low, which means that the goldsmith took some of the gold for himself and mixed in another cheaper metal. I have no idea what actually happened to the goldsmith, but my guess is the king was none too happy to find out that he'd been cheated. Now, I think this is a great story because it has to do with density and a really clever solution to a tricky problem. Some experts say that this story isn't completely true. There are a number of things that they don't quite believe about it. That may be the case, and it may be that Archimedes actually used something called buoyancy instead of density to figure out whether the crown was made of gold. Either way, it's a great story. People tell it all the time, so I hope you enjoyed learning about how density let a king figure out whether or not he'd been cheated.